Okay, so today we're going to move on to the final chunk of work we need to be familiar with angle properties. It's at that grade B level now, so we've moved from triangles, straight lines, quadrilaterals, which is predominantly grade ED, into parallel lines, which is grade C, and finally now into the rest of regular shapes. So we've sort of covered triangles, 180. We've covered quadrilaterals. So the other shapes that I've listed on the sheet here are the ones that you need to be able to bounce both ways. So if they give you a five-sided shape and ask you to name it, you need to be able to know that it's a pentagon. And similarly, if they use the word hexagon, you need to know that that is a six-sided shape. So you need to know those related names and sides pretty much from pentagon up to a decagon, which is a 10-sided shape. It's most likely you'll be working with regular polygons. Now, a regular polygon is one that all the sides are the same length and all the angles are then the same. So a square is your quadrilateral regular polygon, an equilateral triangle is your triangular regular polygon. And when you're working with regular shapes, this equality is crucial in enabling us to do some maths with it. So the fact that it's regular means that we can use those properties. So in an exam situation, the chances are you're going to be asked to calculate the size of interior and exterior angles. So first of all, we need to be clear what those are. Well, the interior ones are fairly obvious. The interior angle is the angle that is on the inside of the shape. So at each vertex, each point on the end. So that's your interior angle. And you can see that in this shape, which is a pentagon, there are 5 interior angles, and because it's a regular shape, they're all the same. Now for the exterior angle, what you need to do is think about if you were going to deal with walk around the perimeter of this shape. Let's say you start there, and you're going to walk towards this side, and when you get there, you are pointing in that direction. You then have to turn to get onto the next part of the path to move in that direction. And the turn that you have to do from the direction you were looking at to the direction you're now going to travel, that's known as your exterior angle. And hopefully you can see there, well, if that's an exterior, that's my interior, and they're going to lie on a straight line. Interior. So the first property, the first relationship which links the interior and the exterior is that the interior angle plus the exterior angle will add up to 180 degrees. So you need to know that. Interior plus exterior is 180. So if you know the interior, you can calculate the exterior by subtracting from 180. Or if you know the exterior and you want to find the interior, you subtract that from 180. Now, if we keep moving around our shape, so I've got to that point and now I'm going to move in this direction. So I end up moving from looking in that direction to moving to there. And then I get to here. And I have to turn in that direction. And then I walk to this point and turn in that direction before I get back to the start. Before I return to the start. What it means is as I walk around the shape to get back to where I started from and where I was looking to, I go through 5 turns. And then because I'm back to where I started and I'm looking at the same point, I've actually turned through 360 degrees. So I've gone through 5 equal turns, 1, 2, 3, 4, 5, and in those 5 equal turns I've turned a total of 360 degrees. So to work out the exterior angle, what you're going to do is divide 360 by the number of turns, and the number of turns is the same as the number of sides. I've got 1, 2, 3, 4, 5 sides, so divided by number of sides. So this is a pentagon. So I'm going to do 360 divided by 5 is 72 degrees. So the exterior angle of a pentagon, a regular pentagon, is 72 degrees. So every one of these outer angles is 72 degrees. So that one is 72, that one is 72, 72, 72, and 72. And then the interior angle is going to be 180 less 72, which is 108 degrees. So every inside angle is 108. And that's it, that's the maths. So the grade B questions, and those are the properties that you need to remember. The interior plus the exterior lie in a straight line, so they add up to 180. To find the exterior angle, you divide 360 by the number of sides. Or, if you know the number of sides, then if you know the exterior angle and you want to find the number of sides or identify the shape, then that would be 360 divided by the exterior angles. How many of these exterior angles fit exactly into 360? So let's take a look at a couple of questions before you have a go at some. So these are of past papers. Calculate the internal angle of a regular nonagon. So a regular nonagon, I know, has got 9 sides. It's there. So nonagon has 9 sides. So the first thing I can do is work out the exterior angle, because I've got that 360 degree relationship. So the exterior angle would be 360 divided by 9. So 360 divided by 9 is 40 degrees. So what I've got here, if I just draw part of the shape, I know that this bit out here is 40. So to work out the interior, it would be 180 less 40, which is 140 degrees. Each interior angle in a regular polygon is 120. How many sides does it have? What is it called? So now, if I think that I've got part of this shape, I know that the interior is 120. So I need to get the exterior. So the exterior would be straight line, 180 less 120, which is 60 degrees. So I know the exterior angle is 60, and I want to find out how many of those there will be in a complete turn. So the number of sides would be complete turn, 360. How many times does that 60 go into it? So 360 divided by 6 is 60. Sorry, 360 divided by 60 is 6. So it's got 6 sides, and I know a six-sided regular shape is called a hexagon. Okay, so there's my six-sided shape. So the shape is a hexagon. So that's it. Grade B, angle properties. Hopefully you'll think that that is a relatively easy set of properties to remember or to learn, and a relatively straightforward grade B question to earn marks on. So hopefully now you'll be able to have a go at the past paper questions. I'll do the same as last week. I'll give you this afternoon to submit your solutions, and then I will upload my video solutions this evening for you. Okay, that's it for angle properties then. We'll move on to something new tomorrow.